Welcome to the third part of the differentiation rule series. For this particular portion, we're going to review what the product rule and the quotient rule is in the differentiation rules. And so what the product rule basically says is, how do we deal with a function that is made up of the product of two other functions, so two functions that are multiplied together. And similarly, how do we deal with a function that is comprised of two functions where one function is divided by the other? And so we'll start off with the product rule. So I've given you the product rule in what we call Leibniz notation, as well as the prime notation. And so here we see that what's basically happening is that we're taking the derivative of one of the functions times the derivative of the other, and then we're adding a second term, and that second term is whatever derivative that we did not take in the first term, well, we're going to do that in the second term. So here you see we're taking the derivative of f first times g, and then plus f times the derivative of g. So we took derivative of f in first term, took derivative of g in second term. And so a quick way to remember this is just derivative of first times second plus derivative of second times first. So we can say that again. Derivative of first times second plus derivative of second times first. And so if you can remember that, then anytime you're confronted with something that looks like you need to use the product rule to be able to take the derivative of it, you can just use this simple rule. And of course, you can clearly see this better in the prime notation, okay? For the quotient rule, we see that we have this nice long formula for it. And I'm going to give you an acronym to remember to help you try to remember this. I'm going to go through it first and then give you the acronym. So if we start off, we see that here we see that f of x is what we call the high function, and g of x is going to be the low function. So we take this low function and then take the derivative of the high function, and then we subtract the high function times the derivative of the low function, and then we divide by the square of the low function. And so the acronym that I'm suggesting that you use here is low d high, d meaning derivative of high function. So low d high minus high d low over low squared. And so I'll say that again. Low d high minus high d low over low squared. And if you see, that's exactly what we're doing here. Low derivative of high minus high times derivative of low over low function squared. So if you can just remember those two sayings or acronyms to be able to help you out, then taking the derivative of functions where they need the product rule or quotient rule will get easier and easier for you. So with that being said, let's go ahead and get into doing these four examples here. So our first example, we want to take the derivative of the function g of x. First thing that we notice is that we have a square root of x here, and we know that square root of x can be rewritten as x raised to the 1/2 power. And so with that, we know that we can employ the power function rule. So if we rewrite this that way, now we have two functions being multiplied times each other, so we will use the product rule. So taking the derivative of g, we'll just say, and I'm going to write this in prime notation, take the derivative of the first function times the second plus take derivative of the second function times the first. And so everywhere where you see the prime there, all I'm going to do is just take the derivative of that particular portion with respect to x, and then after I'm done, I'm just going to combine like terms and clean everything up. So moving on to the next step, I know that the derivative of x raised to the 1/2, we know we can pull the 1/2 in front times x raised to the 1/2 minus 1. And of course that 1 here could be written as 2 over 2. And we'll clean that up in the next step. All that times e to the x, and then plus, here the derivative of e to the x, we learned from the last video that the derivative of e to the x is just e to the x times x raised to the 1/2. And so now here we see that this x raised to the 1/2 minus 2/2 is just going to be x raised to the negative 1/2. So on this next step, we are here. And then of course, at this point, we can go ahead and put everything back into its form where we have the square roots and all that. Of course, here we have e to the x in both terms. So I'm going to go ahead and factor that out. And this e raised to the negative 1/2 x is the same as 1 over square root of x. And since I have a 2 here, we can rewrite it this way. Plus, we factored out that, so all that's left here is x raised to the 1/2, which is square root of x. And so our final answer here is just g of x is equal to e to the x times 1 over 2 times square root of x plus square root of x. Okay. All right. I'll go ahead and bump this down just a little bit, just to give us a little separation in between the two problems here. So on this next example, you notice that we have two binomials that are here. And one of the things that we could do is just use the FOIL method or some form of convolution to be able to multiply these two together. And then we would see that this ends up being a polynomial, and then we would use the power rule. However, we're going to use a different approach here by using the product rule, since we have one function being multiplied by another function. So if we take the derivative of this, employing the product rule again, we take the derivative of the first function times the second, plus now we take the derivative of the second function times the first. And so looking here, we know that the derivative of 2p is just 2. Okay? And so we know that because if we were to put the 1 there, this would be 2 times 1 raised to the 1 minus 1. And of course, 1 minus 1 is 0. Anything raised to the 0 power is 1. And so all this would end up being 2. A more simple way to think about it is when we take the derivative of a line, the derivative would always be its slope. And of course, in this case, the slope is 2. Of course, the derivative of any constant is 0 times this. Sorry. And so for here, when we take the derivative of 4p, that would just be 4. And of course, the derivative of any constant is 0 again. And then we just write the 2p minus 33. And so from this point, we're just cleaning up. We know that 2 minus 0 is just 2. And we know that 4 minus 0 is just 4. So all we need to do is multiply through now. So that would be 8p minus 2 plus 8p minus, and that would be 12, 113. So 132. Okay. And so now from here, we just combine like terms. And this will be 16p minus 134. And so the derivative of this particular function, or polynomial rather, would just be